What if the bizarre laws of quantum mechanics don't just apply to atoms and particles, but to everything around us, even everyday objects? In 2025, physicists shattered one of the biggest walls between the quantum and classical worlds, proving that quantum weirdness doesn't stay confined to the microscopic. The 2025 Nobel Prize in Physics went to 3 American scientists who did something extraordinary. They made quantum mechanics visible on a macroscopic scale. Their experiments reveal that the entire universe, from light bulbs to living beings, dances to quantum rhythms. And the implications for technology and reality itself are mind-blowing. This year's Nobel Prize in Physics was awarded to John Clarke from the University of California, Berkeley, Michel H. Devoret from Yale University, and John M. Martinis from the University of California, Santa Barbara. Their discovery? They demonstrated quantum tunneling and energy quantization in large-scale electrical circuits, proving that phenomena once thought exclusive to subatomic particles occur even at human-engineered scales. In simpler terms, they showed that quantum mechanics governs not just the invisible, but the visible, bridging a century-old scientific divide. So what exactly did they prove? And why does it matter? Let's break it down. Fact 1: everything is quantum. To understand this year's Nobel, we have to rewind to classical physics. In our everyday world, objects behave predictably. If you throw a ball, it follows a clear path. That's Newtonian mechanics. But zoom into the atomic scale, and reality unravels. Particles can be in 2 places at once. They can teleport information instantly through entanglement. They can pass through barriers without enough energy to climb over them. That's quantum tunneling, the very phenomenon these Nobel-winning researchers demonstrated on a macroscopic scale. Their experiments showed that under extreme conditions, even engineered electrical circuits can tunnel like subatomic particles. This collapsed the border once separating quantum from classical, meaning the universe itself is one continuous quantum system. Fact 2: quantum tunneling on a chipper's how they did it. The team built tiny electrical circuits cooled to near absolute zero, creating what are known as superconducting quantum circuits. These circuits allow electric currents to flow without resistance, isolating pure quantum effects. Using these, Clarke, Devoret, and Martinis observed quantum tunneling where electrical charges crossed energy barriers spontaneously, something utterly impossible by classical physics. They also saw energy quantization, which means even in continuous circuits, energy jumps in fixed quanta, just like electrons and atoms. This was the first time scientists proved such behavior in a system large enough to be engineered and manipulated, an actual bridge between quantum theory and physical technology. Fact 3: from electrons to circuits. For decades, quantum mechanics was confirmed only in isolated particles, atoms, photons, electrons. But in 2025, these scientists showed that even large clusters of billions of electrons can behave quantum mechanically as one wave function. The experiment blurred the distinction between the microscopic and macroscopic worlds. Their circuits could exist in a superposition, being in 2 energy states at once, like Schrödinger's cat being both alive and dead. This finding forms the foundation for the quantum computers being built today by companies like Google and IBM. In fact, John Martinis once led Google's quantum AI project, the same team that achieved quantum supremacy in 2019. Fact 4: quantum weirdness explained. Let's talk about quantum tunneling, the effect at the heart of their Nobel-winning experiment. Imagine tossing a ball at a wall. In classical physics, it's either too weak and bounces back or strong enough to break through. In quantum physics, there's another option. Sometimes, the ball just appears on the other side without breaking the wall at all. Particles can borrow energy from uncertainty itself to cross barriers randomly. That's the essence of tunneling, and this phenomenon explains how nuclear fusion, electronics, and even life processes operate. By creating macroscopic systems showing these behaviors, the 2025 Nobel team proved that tunneling isn't just a mathematical curiosity, it's the engine of the universe. Fact 5: energy comes in chunks. These circuits also confirmed another fundamental concept: energy quantization. In our classical view, we think of energy as smooth and continuous. Quantum physics reveals it exists in discrete steps, or quanta. That means an atom or circuit can't take on just any energy, it can only jump between fixed energy levels. This discovery confirmed that nature's energy ladder is universally quantized, even in macroscopic systems. John Clarke said, "It still shocks me how these abstract quantum laws manifest in human-made devices." Fact 6. The big picture. So why does this matter? Because it redefines the limits of physics. For decades, scientists divided the universe, tiny, quantum things versus big classical objects. This Nobel Prize erased that line. It proved that quantum rules govern everything from atoms and molecules to machines and matter we can see and build. It's also a major leap for quantum computing because it shows we can manipulate large quantum systems without losing coherence. This breakthrough brings technologies like quantum sensors, ultra-secure communication, and AI-driven simulations closer to reality. Fact 7. Implications for reality. Here's the paradox. If the universe is truly quantum, then even you exist as a collection of possible wave functions collapsing every time you make a decision. Every atom in your body obeys the same quantum rules as electrons in the experiment. Physicists like John Clarke said these results force us to see reality not as mechanical, but probabilistic, a continuous interplay of possibility and observation. In short, we don't live in a classical world built on certainty. We live in a quantum universe, full of probabilities and interactions that determine everything from subatomic particles to consciousness itself. Conclusion. The 2025 Nobel Prize in Physics proves one profound truth. The universe isn't mechanical, it's mystical, mathematical, and deeply quantum. From the tiniest particle to the largest planet, everything obeys the same uncertain rules. Quantum mechanics is no longer a theory of the microscopic, it's the language of all reality. Welcome to VibeVerse, where science meets mystery and reality becomes stranger than imagination.